Hello and welcome. You ever had that problem before where you take a center drill and you drill a hole exactly where you want it? Put a pilot drill in there, got a pilot hole, and you want to go up in size to about a 1/2 inch and you can't get it in there? Most drill presses don't have enough travel. Even if you plan things right and you put that one in and drill a hole, a lot of times that won't fit. And then if you want to ream it, forget it. Well, you can drop a table, but then you lose your horizontal reference on the table. So there's no real good way to drill holes accurately unless you got a mill. But I got a fix for that. I think you will find it interesting. And well, let's get started and I'll show you what that fix is. Well, here's the fix. A square column on the drill press. It's got a screw to raise it up and down, ball bearing guide. This one here is adjustable so that you can level your table. And we got a hand crank right here to raise it up and down. Okay, this drill press column is 2 3/4 inch. I've got a piece of thick wall tubing here. There's a bearing fit there, but it's thicker down in there. And it's 3 inch, and I'm going to turn it down to 2 3/4 inch. And to do that, for my small lathe, I've got to have some way to hold the center on this end, so I'm going to weld a cap on this end, and I'll be able to chuck this end to my chuck, and then hold it with the center on this end. Wow, looks pretty true. Now I just need to turn that down to 2 3/4. Yeah, my lathe will only handle about 10 thousandths at a time. It's going to be a long process. Well, there's probably a better way to do this. I'm cutting a notch out of this tube to weld to the top of my column. Bandsaw would have been good. I don't have bandsaw. Not one big enough to do this. Okay, there's my drill press column, the top of it. I haven't got the square tubing for the column yet. I don't know whether I'm going to get 3x4 or 3x6 or 4x4. I know where there's a piece of 3x6 I may pick up. This is 3x6, and I was going to mount it like that and weld it here. I'll probably put a cap on top of it, weld it all around here. And my drill press head will sit right there. I gain 2 inches in depth. That's what this is, 2 inches right there. 2 inches in depth on my drill press, so that's a plus. I could have mounted it inside, but by mounting it on the outside like that, I get extra depth. So Might as well do it if I got the opportunity. Yeah, this base is 1.5 by 2.5, 1/8 inch wall tubing. That's what that is right there too. And then 4 by 4 1/4 inch wall. I think it's going to be plenty solid. There's the tube welded to the top. This right here is a clearance for the motor on the drill press. And the head will slip right over that. I'm thinking it's going to work out really good. Okay, as usual, I'm going to make do with some surplus steel I found. These plates right here are identical. I got a bunch of surplus bearings, probably fairly expensive bearings, but I got a bunch of used ones. Some of them are good, some are not. I'm going to mount them right here and right here. Hopefully right here, I think. I'll put an arm on here and have the bearing mounted right there. And this one mounted right there. Table mounted out here, that gives it a lot of support. In the front here I'll have a place to mount my table, and back here a clamp to clamp it to the column. It'll squeeze it together. But we should be accurate, moving up and down within about 10 thousandths, I would think. 15. Okay, right here's the slide that slides up and down on the 4-inch column. The 4-inch column goes right here, and there's a bearing here and a bearing here, and that's the table out here. There's a pin right here, and that's what I'm making right now. This pin right here. It's what I got in the lathe right here. And I started out with this lathe tool right there, and it works pretty good. That's what I cut this first bearing fit with. But then I switched to this tool. It's a grooving tool. It's for cut off and grooving. And this extension here, I have another video on. That's a thing I came up with. There's a support underneath that sits on and solidifies the cutting tool. But it works really good for cutting between two shoulders like that. And I really wanted to cut both ends of this shaft. I didn't want to flip it over, because if my chuck is a little bit off, then each end will be slightly different relationship. It won't be concentric to each other. So right now I'm going to cut the reduced sections on each end. These right here. Now the diameter of these is fairly critical. This distance here is not, but the overall distance of that is very critical. It needs to be 4 inches or slightly under. So the only way I know to do that, I could turn my compound and crank it over that far, but that's quite a ways to go. So I'm just going to measure 1.5 inches from this shoulder, which is where the tool is right now, and then cut down to I think it's 5/8 in diameter, and then I'll measure the whole distance with the caliper there. The spacing, I mean the having it exactly centered is not critical, but this distance is. So let me cut this, and then I'll measure over with calipers exactly 4 inches. Okay, there's 0. Now I got to do a little math. Okay, I've got to go 179.5 thousandths. So I'm going to go 175 and then remeasure. I got 6, 25, 35, 45, 645, and I need to be 625, so that's about 20 thousandths, which is 10 thousandths on my compound, or cross slide. So I'll take off slightly less than 10. Okay, I'm going to set my carriage stop. If you don't have a carriage stop, you need to make one of these things. Super handy. Now I can cut down just and not go too far. Yeah, I forgot to lock down my tailstock. Hopefully that's it. That's a little better. Okay, here's what I'm making. I'm cutting down right here and here, and these are going to be eccentrics. I'm going to cut down right there and right there to the top of that offset pin. And then I'm going to turn these down. And then I'll put it in my forge jaw to cut those eccentrics. Right now I'm establishing this length right here. Well, I've got part of it made there. Now I got to cut the offsets, put the forge jaw in here. Okay, I'm going to have to make a new center right here. Thing is, and I don't know what I'm going to do about this, I don't know if I'm absolutely straight. I think I'm going to take a dial indicator, go to the high side here and the high side here and see if I get the same number. Maybe stick it to my cross slide. Actually, I can just do like this. Just barely touching there. Barely touching. Yeah, that's pretty straight. Pretty good way to do that, I think. Hopefully I didn't move it at all. But I don't want it to move when I turn it on. How much offset do I want? Probably should have checked that first to see how much I got. Looks like about 1/4 inch. I was going to go for between 1/8 and 1/4, so I'm going to say that's okay. Looks good. It's like my insert's trying to come loose. Can't imagine why. Oh, not good. Broken insert. Could be worse. That's the adjustable pin to level the table. I just beveled the other side of the hole. Half 16 lift screw, or lift screw threads. Lift screw nut, actually. Cool. But here's what we're building for the drill press column slide. These are just my hole locations. I've got both the fixed guide finished with the bearings pressed on there, and this one's the adjustable roller guide on the back side of the column, or front side of the column. That one will go right here, and this one will go right here. That looks kind of complicated, but it's really quite simple. See, 1, 2, 3, 4, 5, 6, 7, 8 holes to drill. This is some surplus steel off some machinery that I'm going to utilize. These holes won't be used. I made a template. I'm not going to go by the template. It's just more or less to double check, make sure I'm drilling in the right location. I use the mill to locate the holes with the mill. Got the same thing here. This will go, let's see, that will bolt to that right there. Got a steel plate. Mounts right here. And there'll be a hole here for this roller right there, and this roller will mount down here. This will be where our table mounts on the drill press. Well, let's get started drilling. Got a lot of holes to drill. Okay, if you want to drill and tap with any kind of accuracy, and I'm sure some of you already know this, you've got to be able to keep the tap lined up in the hole. The tap handle has a hole in the top, and you can put a center in your chuck and use your chuck to line up the top of the tap. Well, if you don't plan ahead and you drill the hole and you don't have room to put that in there, then if you got a round column mill and you raise the top of your mill, then you lose your reference this way. Same with the drill press, which is why we're building the drill press table that we're building today. I just wanted to point that out. I just barely had enough room here, and I put a small center drill in there, and it allowed me to, I just didn't plan ahead enough here. I'm out of travel on the quill. We're going to fix that with this drill press modification. Okay, I'm getting ready to drill my side plates. You probably can't read that, and it's upside down, but I got all my moves drawn out there. These will be 3/8 and reamed to size, and that'll be 1/2 inch and reamed to size. Reaming to size is probably a little fanatical, but I don't want any slop in the screw holes. They're minimal anyway. Well, having this thing is really good. Even with a DRO, you can misread something, and that'll tell you if you're a significant distance from where you should be. It's a little mess. Got some cleanup to do. But all the pieces are done for the slide. Let's go take a look. There it is, halfway put together. Just got those bolts sitting in there loose. I got these pieces on there tight, but now I got to fit it around the column. Got this right here. That's the one that's concentric, and that will go on the back right here. And this one here, it's got the eccentric on it. It fits in the bottom right there. Now let's put it on the column and I'll show you how it works. Hopefully it fits. A little awkward. Probably wouldn't hurt to have a helping hand. Now, moving this eccentric pin on the bottom will level the bracket. The table hangs out here. I'll have to square that to the column eventually. I'll wait till I get the table on there and fine tune it to make it square to the column. And then these lock down, of course, when it's level. Thing's a little bit heavy. This is my half 13 threaded rod that lifts the whole assembly. Got a burr on that end. Well, there's the lift screw in place, approximately anyway. I'll probably mount a bracket right here, and then I've got some tapered roller bearings that'll hang from. And I'll probably have another block like that right here and have a hand crank out here with a sprocket and chain drive. I thought about making it a power drive, and I may eventually do that. It'll take 13 cranks to move the table 1 inch, which may be a little excessive, we'll see. Should be pretty easy to move. Some kind of cheap gear motor might drive it pretty good, but so far I haven't been able to come up with a gear motor that's cheap enough for my budget. But we'll see. I made this about 10 thousandths wider than the column. Now the column's supposed to be 4x4, but it's not machined. And it was 4 inches and about 10 thousandths. And that's about what it averaged all the way up and down the column. And I made this 4 inches and about 20 thousandths. So it's 6 or 8 thousandths oversized on the width. And that allows, when I loosen the bolt in the back, the bracket spreads open and allows it to travel. Then when it clamps down, technically it's probably got a little bit of clearance right here, but I don't really know that. I hope it doesn't. If it ends up being a problem, I'll put some kind of shim in there, but I don't think so. I mean, when it's tight, there's no slop in that whatsoever. So I think I lucked out and did good. It's hard to predict exactly how square this tubing will be and what dimension, just because it's not machined. But I think it'll be plenty close. Most of the time, you know, within a few thousandths is more than close enough for the work that I do. Especially if you're dropping the table down to fit a reamer in or whatever, and you got the reamer that far from the chuck, it's not going to be a major problem if it's a couple thousandths off. If I was doing milling operations, it would be different, but for drilling, this should be plenty accurate. Well, that concludes part 1. This is going to be a 2-part video. I got a lot of work to do yet. I'm going to put the left screw here with the bearings and put the drill press head on there and the table. Got a don't remember what thread mount that is, but I got a drill and thread for the table mount right there. But that concludes part 1. Stay tuned for part 2. It may be a couple weeks out, but it'll happen. Thanks for joining me.